Welcome to our Honors Geometry Lesson 1.2, Ordered Pairs as Points. So this main concept is based around a type of geometry. Now in our last lesson there was Euclidean synthetic geometry in a little box, which basically again is the geometry we exist in. Now plane coordinate geometry, which then we'll look at Euclidean plane coordinate geometry, which is the most common type. So plane coordinate geometry is the study of geometric figures using points as ordered pairs of real numbers. So when you think about anytime you've put things on a Cartesian coordinate plane or coordinate plane, that is using ordered pairs of real numbers. So you were performing plane coordinate geometry. So the study of geometric figures, and figures can be points, can be lines, segments, shapes. The study of geometric figures using points as ordered pairs of real numbers. So plane coordinate geometry, you can think of taking place on a plane or having ordered pairs or coordinates. So our description of a point in coordinate geometry or plane coordinate geometry is that a point is an ordered pair of real numbers. So you'll see that is slightly different than our description of a point from synthetic geometry. Now the second one here, description of a line. A line is a set of ordered pairs of real numbers, x, y, coordinates, satisfying an equation of the form ax plus by equals c, where a and b are both not zero. So that's a really long definition or example of what's known as the standard form ax plus by equals c. That's what's known as standard form or standard equation of a line, which was covered in Algebra 1, but we will take a little bit of time to look at that again in this lesson. So our description of a line, though, a line is a set of ordered pairs satisfying an equation of that form, ax plus by equals c, where a and b are both not zero. So we're going to look at some of these applications of plane coordinate geometry. So example 1, the point B has integer coordinates. What are they? So just a refresher on taking the coordinates from a point on a plane. So again, brief refresher. Remember, you always start at the origin, or 0, 0, and go from there to identify your coordinates. So to get to B, we had to go left 2 and up 3, which means we were at a -2 for our x and a +3 for our y, so -2, 3. Now we're going to look a little closer at this idea again of standard form of a line. So standard form of a line says ax plus by equals c. Now, a couple things to keep in mind with that. X and y would be our coordinates, like -2 and 3. And then a, b, and c are variables as well. If neither a or b are 0, so if neither one of these values are 0, we always end up with an oblique line or a slanted line. So an example of that would be x plus y equals 3. So x plus y equals 3 would be an oblique line, meaning it has a slope that is not dealing with x being 0 or y being 0. Then in our next piece, if a equals 0, the line is horizontal, meaning y equals a number. So if a equals 0, the line is horizontal, y equals a number. So being a horizontal line, that would be our example here. if we had something like y equals 1.5, we would have a horizontal line where all of our y values were at 1.5. And then if b was 0, the line ends up being vertical, meaning x would equal a number other than 0 in our equation. So our equation for a vertical line could be something like x equals -3. So anytime b equals 0, anything times 0, so that y times b would cancel, leaving us with then the x equals our value, so x equals -3. Then we have my favorite form for writing lines, slope-intercept form. So slope-intercept form, again, a refresher from algebra. Slope-intercept form is y equals mx plus b. Now in slope-intercept form, the b represents our y-intercept, meaning that's where our line crosses the y-axis or where x equals 0. So if we look at our graph here, that is our y-axis. So b would be wherever the line crosses the y-axis. And then in slope-intercept form, m always represents the slope of the line. And a refresher of slope, slope is the ratio of the change in y to the change in x, or sometimes we simplify that to say rise over run, change in y over change in x, delta y over delta x. There's many different ways to say it, but simply what that means is y sub 2, so one of our y coordinates minus y sub 1, our other y coordinate, and then x sub 2 minus x sub 1. So if we look here, example 2 says graph the line with this equation. So there's a few different ways that we can do this graph. One way, again, is to apply our x and y t-table. So using an x and y t-table, we can choose some coordinates for x and then solve for y by plugging that into our equation. So for example, if I plugged in a 0 for x into this equation, y equals 2x minus 2, 0 times 2 is 0, minus 2 would give me the y value in -2. If I plug a 2 in, 2 times 2 is 4, 4 minus 2 is 2. And then put a 4 in, 4 times 2 is 8, minus 2 is 6. So we could create an xy t-table, get our coordinates, and then put those points on the graph to create our line. So 0, -2, starting at our origin, over 0, down 2, so there's our first coordinate. 2, 2, starting at 0, 0, right 2, up 2, there's our next point. And then at 4, 6, we'd go back to 0, 0, go right 4, up 6, and that gives us our third point. Anytime you use this approach of an XY t-table, in order to graph a line, it's required to have 2 points, but mathematically you always want to use 3 to ensure if one of the points is not on the line, then you want to double check to see if you made a mistake. Now, the other way that we can go through and do our graphing here is simply by looking at the equation. If we know our y-intercept is at a -2, we can start with that to graph. So we would start at our y-intercept at -2. Our slope is a +2, or 2 over 1. So from the -2, I could go up 2, right 1. Then my next point would be up 2, right 1. Next point, up 2, right 1, and so on, up 2, right 1. So that's another way that you could do this graphing without creating the t-table. And in part B, we have y equals a negative 1/3 x plus 1. So in this case, negative 1/3 multiplied by x plus 1. So I'm going to use both approaches again. First, using the xy t-table, choose some points to put in for x or some values. I always use a 0. That allows us to figure out our y-intercept if you don't want to just take it from the equation. And then because there's a fraction here, I want to plug in numbers for x that are divisible by the denominator to avoid getting fractions or decimals. So I'm using a positive 3 and a negative 3 because both can be divided by our denominator at 3. So if I plug in my positive 3 for x, negative 1/3 times a positive 3 is a negative 1 plus 0, or plus 1, sorry, negative 1 plus 1 gives me the output of 0. Then apply that with the negative 3 in for x. Negative 3 multiplied by a negative 1/3 is a positive 1, plus 1 more gives me the output of 2 for y. So then I could plot those 3 points, 0, 1, 3, 0, negative 3, positive 2, and then connect them to get my line. Otherwise, if you like the approach of just taking our equation and applying our parts, you always start at the y-intercept, so we're starting at a positive 1. So I put my point at 0, positive 1, and then from there, we follow the slope. So our slope is a negative 1/3. So that means down 1 and right 3. So then our next point would be down 1 and right 3. Or you could do the opposite, up 1 and left 3. Up 1 and left 3. So either approach works to get your line. Now, example 3, I apologize, it misprinted on the 2 pages, but example 3, which is actually on our next page here, says write an equation of the line containing the following coordinates, or the following points. So in A, they give us 3, 1, so the coordinates of 3, 1, and negative 2, 11. So in order to write the equation of a line, I always write mine in slope-intercept form. So the steps in order to do so are 3 steps here. The first step is to find the slope. So in this case, change in y, y2 minus y1 over x2 minus x1. So our y coordinates, 11 and 1, go on top, 11 minus 1, and our x coordinates, negative 2 and 3, go on bottom, negative 2 minus 3. So then we end up with 10 over negative 5. 10 divided by negative 5 gives me a y-intercept, or a slope of negative 2. So my slope is negative 2, or negative 2 over 1. Then what you want to do is you set up your equation in y equals mx plus b, slope-intercept form, and you're going to plug in the slope that we just found and one set of your coordinates, so either set, to solve for b. So my slope is a negative 2, so I replace m with negative 2. My coordinate is 3, 1, so the 3 takes the place of x, and the 1 takes the place of y. Then I'm going to solve this equation for b. So a negative 2 times positive 3 is a negative 6. So we have 1 equals negative 6 plus b. Add the 6 to each side to get rid of the negative 6, and we end up with 7 equals b. So then, our final step, we can now use our slope, which we found in step 1, and our y-intercept, or b, which we found in step 2, to write our equation. So y equals mx plus b, y equals negative 2x plus 7. So our b right here and our m right here. So in example B, we can do the same. Our coordinates are 4, 9, and negative 2, 6. So step 1, to find our slope, change in y over change in x. So 6 minus 9 on top, negative 2 minus 4 on bottom. That gives me a negative 3 over a negative 6. Negative 3 divided by negative 6 is a positive 1/2. Now, because we're dealing with slope, I would advise to leave it as a fraction, not to write it as a decimal. Now, in our next step, we're going to set up the equation in slope-intercept form, plug in the slope, and plug in one set of the coordinates. So in this case, our slope is 1/2, x is 4, and y is 9. So I'm using my first coordinate here. 1/2 times 4 is 2. So 9 equals 2 plus b. Subtract 2 from each side to solve for b, and b equals 7. So then we're going to use step 3, using m and b, rewrite our final equation. So y equals 1/2 x plus 7. And then example 4. Example 4 says convert the equation into slope-intercept form and graph it. So they give us standard form. They want us to rewrite it into slope-intercept form. So simply what that means is we want to take standard form and solve it for y. So we want to get y alone. And that will give us slope-intercept form. So looking at our first one, A, 3x minus 2y equals 6. I'm going to start to solve for y by subtracting 3x from each side. Negative 2y equals negative 3x plus 6. And then to get y alone, I'm going to divide everything by the negative 2. So y equals negative 3 over negative 2x plus the positive 6 divided by negative 2, which simplifies to y equals 3/2 x minus 3. And then, using that equation, I'm going to graph my line. So I'm going to use the shortcut and start at the y-intercept in negative 3. So I know my first point is at a negative 3 at the y-intercept. Then my slope is 3 over 2, so I'm up 3, right 2. Rise over run, up 3, right 2. Now we have our points, we can connect them, and there's our line. In part B, our standard form is 2x plus 5y equals 10. So in this case, we want to, again, solve for y. So in order to start that, we will subtract the 2x from each side, and we have 5y equals negative 2x plus 10. Then we'll divide everything by 5, and y equals negative 2/5 x plus 10 over 5. And simplify that, y equals negative 2/5 x plus 2. So now, in order to graph that, my y-intercept is at a positive 2, so I'm up 2, and then my slope is a negative 2/5, so I'm down 2, right 5. And then to get my next point, if I did down 2, right 5, I'd go off the graph. So we can go back to that first point and do the opposite. Up 2, left 5, and there's our third point. We can draw our line. And now we are on to our final example here, example 5. So now we're taking that idea and applying it to a real life situation of a water park slide. So not real life for everyone, but if you build water park slides, there you go. So in example 5, it says, the maintenance crew at Splash and Slide Water Park have found that their main attraction, the Big Kahuna Water Slide, needs some additional vertical bracing. So vertical bracing being the pieces here. Then they give us some information. There already exists a 10-foot vertical brace near the bottom. So we know this vertical brace near the bottom is 10 feet. And a 46-foot vertical brace near the top. So here is our 46-foot vertical brace near the top. That is 72 feet from the bottom brace. So the distance between this first brace and this last brace is 72 feet. 2 more vertical braces are needed that are equally spaced between these 2 braces. Model the slide with a line letting the bottom of the slide be the point 0, 10. So our coordinate of 0, 10. So what they're saying to do is think about just this slide, the bottom piece of the slide, right here, this dark line, being a line. The bottom meets this brace at the coordinate 0, 10. So I can figure out my other point because of my information. From this brace to this brace, it was 72 feet. That is the x-axis, so I went right 72. Then the height of this point was up from the bottom 46 feet. So this coordinate is 72, 46. So what are the possible coordinates for the top of the slide? It would be 72, 46. Then in part B, find an equation for the line modeling the slide. So if we're using this line to model the slide, the bottom line here, well, we know our 2 coordinates are 0, 10 and 72, 46. So we can use that, and we can do the same thing we did here in example 3 in these 3 steps. So first we want to find our slope, which in this case, our slope would be change in y over change in x, 46 minus 10, and 72 minus 0. That comes from these 2 coordinates. That gives us 36 over 72, which simplifies to 1/2. Now, to get my y-intercept, we actually don't need to do any math on this one because it was given to us. The y-intercept is when the x-coordinate is 0. So if we have the coordinate 0, 10, my y-intercept is 10. So to write this equation in slope-intercept form, it'd be y equals 1/2 of x, 1/2 times x, plus 10. And then in part C, they want us to figure out how long should each of the additional braces be. So this one gets a little tricky because we're figuring out the length, or this height here, of each additional brace. In order to do that, we would want to figure out their x values on the bottom. Well, here's how we can do that. We know this is 72 feet across. In that 72 feet, we have 1, 2, 3 total braces. So what I can do is 72 divided by 3 means each one of these braces, to be equally spaced, should be 24 feet apart. So 72 divided by these 3 openings is 24 feet. So that tells me this brace here has an x-coordinate of 24. The second brace here, or third brace technically, has an x-coordinate of 48. So to figure out the height of our additional braces, we're going to plug these x values in to our equation. So y equals 1/2 times 24 plus 10. Half of 24 is 12, plus 10 is 22. Then in part C, 1/2 times 48 plus 10. Half of 48 is 24, plus 10 is 34 feet. So once we knew the x-coordinates, we could plug that into our equation to get our y-coordinate for our output, which are the heights of our additional two braces. So as you work through the practice problems for today's lesson, again, I encourage you, as long as you're staying on task, to talk about these problems, converse with your peers, problem solve together where need be. Make sure that you truly can understand these concepts as well as possible. If you need to come back through the video and rewatch sections, you're more than encouraged to do so. And of course, if you need help with understanding any parts of the notes, practice problems, or some of these definitions, please don't hesitate to come ask for help.